morning. My name is James and I'll be presenting the webinar today, and I'm pleased so many of you have been able to join this session. The objective of this webinar is to identify in-school variation and the differences in performance within a school that should be the subject of this intervention. This is displayed in a subject profile tool in 4Matrix, and this is the tool we will be mostly looking at today. So this is the subject profile tool. I've got a series selected down here. So the first thing we're going to do is explain what we mean by in-school variation, what we use to measure it, and how that measure is calculated. In-school variation, or ISV for short, is the variation in provision as experienced by different groups of learners. So inherently, ISV is a school effect which can affect the outcomes to learning for students. It can have a positive or negative influence upon learning effectiveness. We attempt to measure this effect by the use of a performance measure known in 4Matrix as the residual. So the residual represents how well pupils in a subject did in comparison to other subjects they studied within the school. So the key thing to understand at this point is that the calculation is entirely internal. So it does not compare against national data at all, in contrast to other measures such as Progress 8. So in this example, we're going to look at how the residual for history is calculated. In this scenario, it's for an actual results series, and we can start to look at this through the subject profile. So I've got history selected from the subject select panel on the left of the screen. And if we look at the results in a series for Laurel Adams, so you can see here she's got a selection of results. We can use those results to calculate the residual. So all grades have got point values. For 9 to 1 grades, it's usually the case that the grade number is also the point value. Different types of vocational subjects will have different grade values depending on the grades that can be awarded in that subject. So the old A star to G grades will also have point values attached to them. So to calculate the residual, we first need to find the average points value of Laurel's grades. So these are her grades across the top here. We then convert them to the points value. So you can see the D star 2, for example, in the Sport BTEC is worth 8.5. D2 in Business BTEC is worth a 7. If we total all those up, it comes to 54.5. And the average of those points is 4.95. So 54.5 divided by 11 subjects. So the residual for Laurel in history is minus 0.05, minus 0.95, which is the 4 she got in history, minus the average of her points in other subjects, which is 4.95. So to calculate the subject residual, what we need to do is repeat that calculation for every other student that studies history. If we then take the average of all of those pupil residuals, it means we get a residual for that particular subject of 0.04. So what does that number actually mean? So the numeric value of the residual corresponds to the 9 to 1 grade scale. So a score of 0 would indicate that on average, pupils are doing exactly as well in that subject as compared to their other subjects. A score of 0.04 is so close to 0 as to say, in this case, the pupils in history are attaining on average approximately what they're attaining in their other subjects. Back into the subject profile tool and see what that looks like in reality. So we can see Laurel here. If I right click on the dot, we can see all her grades over here. So you can see the grades in green are the ones that are higher than our average, and the ones in red are below. The subject we've currently got selected is shown in bold here. If we hover over her dot, you can see her average is 4.95, which is what we calculated on the other screen. And the grade she's attaining in history is 4. So if we look at the graph as a whole and explain what's going on here. So the x-axis represents academic range. So a range is the average of each pupil's grades from highest to lowest values in rank order. So you have the highest attaining pupil on the left and the lowest on the right. So you'll notice if I start to move the cursor, it changes what pupils displayed on that line. If they've got a grade in the particular subject, it will show that. Otherwise, it just shows their average grade. The left y-axis is fixed to the 9:1 grading points for reference, and the right y-axis is dynamic in that it will show the correct grades for the selected qualification subjects, which means the right axis could also be 9:1, or it could show a strategy of vocational grading such as DMP. So if I select Sport BTEC, you can see that axis changes to represent the grade values of that particular subject. So just looking at the green line, as I said, it's the entire cohort, basically, their average grades. You'll notice if I select different subjects, that doesn't move. And it's unique to the particular series you've got selected. Looking at the panel in the bottom left, it shows the measures for a subject. So if a group is selected using the filter panel, so if we look at chemistry, I can then select a particular class. And that basically then only shows me the pupils that are in that class. We've also got this toggle up here, which is hide pupils not in group. You can see with it switched off, the pupils who are studying chemistry but aren't in 11 SC1 are then faded out. I can choose to hide them from the graph entirely. So moving on to what this is actually telling us. First thing to point out is that the residual is a zero-sum game. So it's all based on a single series of data, looking at average grades with no external comparisons. This means that some subjects will always have a score of less than 0, and some will have a positive score. It also means that even pupils with consistent grades will have results below the residual line in some subjects and above in others. So what we are looking for are examples where the score or the pupil is a long way out on average. So if we go back and have a look at history, which we know has got a relatively neutral residual, you can see there's a rough spread of dots by grades in that subject, both above and below that green line. So if we go back and have a look at chemistry and just try and draw out some particular pupils. So looking at Aretha in the top right. So we can see that basically she's doing a lot better in chemistry than what she is in all her other subjects. So her average grade is 3.2 and she's actually getting a 6 in chemistry, so nearly 3 grades higher than her average. Conversely, if we look at Obi over here, see she's getting a 3 in chemistry against an average grade in her other subjects of 5.83, so nearly 3 grades worse. When looking at an individual, it's likely the class teacher will already be aware of their difficulties. It's important to consider that if they are meeting their targets, you may not have realised that something is affecting their outcomes in their subjects that's not having the same effect in other subjects. So this could be down to a send issue, a poor choice of option subjects, or something as simple as the pupil being distracted by the person next to them on your seating plan. So again, if we look at Obi's results in a bit more detail, you can see actually she's doing worse in all her science subjects compared to her others. Slightly worse in English, Lang and Lit, fairly consistent across the rest, but considerably worse in all three science subjects. So again, when we're looking at individual pupils, the pupil display tool is also quite useful for this. So again, we've got Obi selected. This yellow line represents her average grade. So you can fairly clearly see there, science is not a particularly strong suite of subjects for her. So individual outliers are always worthy of investigation and may reveal a pupil with potential for improved performance who may have fallen under the radar. So we can also look at group residuals. It can be easy to see visually if boys or girls have a different pattern. So again, if we go back to subject profile screen and have a look at a subject that shows this, which is statistics, you can see there's a large difference between the relative residual for boys and girls. The boys are the blue dots. You can see particularly you've got a cluster here of boys who are doing considerably worse, and a cluster of girls here who are doing considerably better in stats than what they're doing in their other subjects. So if we look at the subject summary tool, which we'll come back to and have a look in a minute in more detail, we can have a look at this gender diff column here by sorting by it. And you can see here there's a fairly substantial difference between the relative performance of boys and girls in that particular subject. There's some subjects here that are even more extreme, but I've used statistics because there's a lot more pupils studying it, so it shows the effects rather better. So as this x-axis is arranged by ability, it can also be easy to see whether there is an imbalance between high, middle and low ability pupils. So again, we pointed out these clusters earlier. You can see high to middle ability girls who are doing quite well. And it's these kind of middle ability boys that aren't doing so well. Again, you've got a group of even higher ability girls here are perhaps dropping a little bit further below what they could be achieving perhaps in stats. But again, if we have multiple classes for a subject, as we do for chemistry, subject overview tool can also help us identify class differences. So we've got the classes shown at the bottom. There's a residual column here. Click on the header to sort by it. And we can see this 11 SC3 class has got a much lower residual than all the other chemistry classes. So you can see what that looks like on the subject profile. Again, you can see here that literally no pupil in that class is achieving their average grade across all their other subjects in chemistry, i.e. every pupil has got a negative residual. Filter by other things than class. So you've got the full filter by tool over here. So for example, you could filter by pupil premium if you wanted to, any combination of that, those filters there. Where it might come in particularly useful is looking at research groups, so identifying a particular group of pupils whose performance you want to examine over time. So I've got an intervention group here. I can select that and then see how they're doing in various subjects. So we will now move on to subject level analysis. This will look in a bit more detail at the subject summary tool. So if we sort by residual again by clicking on the header, you can see that German's got the lowest residual and drama's got the highest. So going back to the subject profile and selecting German, again, you can see here we've got a lot of pupils below that green line, and furthermore, a lot of pupils whose grade is considerably worse than their average grade. So you might ask the question of why that actually is. So it could be that this particular subject is mandatory, meaning that perhaps less motivated or suitable pupils are studying it. It could be down to inconsistent teaching. It could be as simple as the subject has an unusually high number of pupils who don't attend school. So U grades will heavily affect the residual. To say they're just coming in to do English and maths, they're on to get 4s in those, but U's for everything else. Every subject they're getting U's for will be heavily impacted by that. When you come to do this sort of analysis in your school, one very common reason that will be offered for why a subject has got a negative residual is that teachers will often claim that their subject is harder than other subjects, hence why pupils do worse in it. It's important to say this does have a genuine statistical basis. So to put the claim more neutrally, at national levels, pupils do attain lower grades in particular subjects than others. So essentially, if you were to calculate the residual at a national level, some subjects would be scoring less than 0 and some more. So modern foreign languages such as German, for example, usually do have a negative national residual. So the question for you in school is it then acceptable for that pattern to be repeated in your school? And I think that some would say yes, it is, and others would say no. Again, that's something for you to decide when you're doing your analysis. So it's worth noting at this point that the subject VA tool in 4Matrix directly addresses this, as it compares grades against national data for different Key Stage 2 start points. So I'll send you a link to a guide outlining how this tool works. We'll also do a webinar on this particular tool at some point in the future. So the other interesting measure to look at is distribution, sometimes called variance. As its name implies, this is a measure of spread. So if we look at the original residual calculation we did for history, we can see how this works. So essentially it's calculated in exactly the same way as a residual, except that all negative values are turned positive. So we're not interested in whether the grade's above or below their average, just merely how far away it is. So again, if we take the distribution of all the pupils' individual variances in history and average it out, we get a history distribution of 0.68. So if we go back into the subject profile and look at history, so we can see that the pupil grades are relatively tightly clustered around the green line. There's only a few pupils that are more than a grade away. So Maria and Tommy here. And this cluster here of 3. Every other pupil is within half a grade, essentially, or within, less than a grade away from their average grade. Where this becomes interesting is you can see 2 subjects with similar residuals may have very different distributions. So a low distribution, which is kind of what we're looking at here, of around 0.6 grades, indicates a tight relationship between teaching and learning. And high distribution suggests a wider range of outcomes in response to the same teaching. So you see, like I said, that history's got a reasonably low distribution. If we go back to the subject summary, find history. We can see that Sport BTEC has got a relatively similar residual to history, so it's a little bit higher, but not anything particularly significant. But it's got a very, very different distribution. And if we look at what that actually looks like, you can see here you've got a massively different spread. So a lot of pupils achieving vastly better in Sport BTEC than what they're doing elsewhere, and a lot of pupils actually doing quite a lot worse. So the explanation for that could lie in exemplary teaching that we can learn from, or an area where students are dropping away from the levels of attainment that they can achieve in other subjects. So that concludes the webinar. In summary, the subject profile, residual, and the distribution are powerful tools for examining in-school variation. So it's kind of worth mentioning that the subject profile tool is actually quite an iconic screen in 4Matrix, as it's the first analytical tool we ever produced back in 2008. So at that time, it was produced in Excel. So I've included a screenshot of what it looks like here. And so hopefully you've seen that things have moved on a little bit since then. But the reason why it was the original tool is it's such a powerful thing to use. Very, very useful for identifying, as I said, that in-school variation. Schools can quickly identify pupils, subjects, and groups that may be in need of analysis, either for intervention purposes or identify what is working well. So just to take some questions we've had going through. One question is, can you get this tool on the online version of 4Matrix? Which is yes. Subject profiles on there, as is subject overview, subject summary, and pupil display. So all the tools we've looked at today are on 4Matrix Infinity. So again, thanks for your time today. Take care and goodbye.